Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about solution of inverse Z transform by residue method. Inverse Z transform, a key concept in digital signal processing. Here, we will explore the residue method, a powerful technique for solving the inverse Z transform. This method is widely used in various applications such as digital filter design and system analysis. Introduction to Z transform and inverse Z transform. Z transform. The Z transform is a mathematical tool for converting a discrete time signal into a complex frequency domain representation. It simplifies analysis and manipulation of signals. Inverse Z transform. The inverse Z transform converts a function in the complex frequency domain back into the original discrete time signal. It allows to understand the time behavior of a system. Understanding the residue method for inverse Z transform. Step 1. Identify poles. Determine the poles of the function which are the values of Z that make the denominator 0. Step 2. Calculate residue. For each pole, find the residue which is the coefficient of the term Z minus pole power minus 1 in the partial fraction expansion. Next, apply the inverse Z transform concept. Use the residue values to construct the inverse Z transform. This involves summing the residues multiplied by the appropriate power of Z. Now we are going to find the inverse Z transform of 2Z by Z minus 2 into Z square plus 1 by method of residues. Here the f of Z is equal to 2Z by Z minus 1 into Z square plus 1. Here f of Z is multiplied by Z power n minus 1. So which value is equal to 2 into Z power n minus 1 divided by Z minus 1 into Z square plus 1. Now Z square plus 1 is factorized into two terms, that is Z plus I into Z minus I. So in next step we have f of Z into Z power n minus 1 is equal to 2 into Z power n divided by Z minus 1 into Z plus I into Z minus I. Now we are going to calculate the residue of f of Z power minus 1 at the point Z is equal to 1. Which value, we know the formula, residue of f of Z power n minus 1 at Z is equal to A is equal to limit Z tends to A, Z minus A into f of Z into Z power n minus 1. So instead of A, here we are having 1. So residue of f of Z power n minus 1 which is equal to limit Z tends to 1 Z minus 1 into 2 into Z power n divided by Z minus 1 into Z plus I into Z minus I. After that Z minus 1 get cancelled. Next we have limit Z tends to 1 2 into Z power n divided by Z plus I into Z minus I. After that we put Z equal to 1 here, we get 2 into 1 power n divided by 1 plus I into 1 minus I. Multiply 1 plus I into 1 minus I, value will become 2. So which value is equal to 2 by 2 which is equal to 1. So now residue of f of Z power n minus 1 at the point Z equal to 1 equal to 1. Now we are going to calculate the residue of f of Z at Z is equal to I. So which value is equal to limit Z tends to I Z minus I into 2 into Z power n divided by Z minus 1 into Z minus I into Z plus I. So after cancelling Z minus I, we get limit Z tends to I 2 into Z power n divided by Z minus 1 into Z plus I. Now we put Z by I. We get 2 into I power n divided by I minus 1 into I plus I. After simplification, which value is equal to 2 into I power n divided by 2I into I minus 1. So which value is equal to I power n divided by I into I minus 1. So by simplification we get which value is equal to I power n divided by minus 1 minus I. Taking minus outside, which value will become I power n divided by 1 plus I, which is the residue of f of Z power n minus 1 at point Z equal to I. Now we are going to calculate residue of f of Z at Z equal to minus I. which value is equal to limit z tends to minus I z plus I into 2 power z power n divided by z minus 1 into z plus I z minus I. Here we are cancelling z plus I divided by z plus I. After that it will become limit z tends to minus I 2 into z power n divided by z minus 1 into z minus I. Now substituting minus I instead of z, we get which value is equal to 2 into minus I the whole power n divided by 1 plus I into 2I. By simplification we get which value is equal to residue of f of z power n minus 1 divided by z power n minus 1 at the point z equal to minus I is equal to minus I the whole power n divided by I minus 1. Now f of n is equal to sum of residues of f of z into z power n. So f of z is equal to 1 minus I power n divided by 1 plus I plus minus I the whole power n divided by I minus 1. Conclusion. The residue method is a powerful technique for solving the inverse Z transform. By understanding this method and its application, you can delve deeper into signal processing and gain valuable insight into the behaviors of systems. Thank you.